Hello students, welcome again to today's lesson. I'm your teacher Alice, and we have been looking at the second chapter of Form 2 work, the chemical families, patterns in properties. In this topic, we said we are going to look at 4 chemical families: the alkaline metals, alkaline earth metals, the halogens, and the noble gases. So in the previous lessons, we have looked at the alkaline metals, and we looked at the physical and chemical properties and also the uses of alkaline metals. So today, we are going to look at the second family, which we call alkaline earth metals. So this marks the part 3. So what are alkaline earth metals? So the alkaline earth metals are the group 2 elements of the periodic table. That one we should not forget. Then the members of alkaline earth metals include beryllium, magnesium, calcium, strontium, barium, and radium. So in this topic, or in Form 2, we only look at the first 3 metals, or the first 3 elements, that is beryllium, magnesium, and calcium. So that is what we are going to look at. Though still the others are still in group 2, though they are past the 20 elements. So we focus with the 3 elements, and we say the electronic arrangement of the first 3 is as follows. That of beryllium is 2:2, that of magnesium 2:8:2, and that of calcium is 2:8:8:2, making it to be atomic number 20. Magnesium is atomic number 12, and beryllium is atomic number 4. So we say each alkaline earth metal has 2 electrons in the outermost energy level, and therefore it is referred to as divalent, meaning di meaning 2. So it has 2 electrons in the outermost energy level. That's why we call it divalent. Then down the group, there's an increase in the number of occupied energy levels, as we have seen here. For beryllium, it has 2 occupied energy levels, magnesium has 3, and calcium has 4 occupied energy levels. So we are saying the number of occupied energy levels increases as you go down the group. So we look at the gradation in size, that is what happens to the atomic size and ionic size of alkaline earth metals. So the atomic radii and ionic radii of the alkaline earth metals increases down the group. So this is similar to the alkaline metals. And we said the reason also was due to the increase in the number of occupied energy levels. So that makes the atomic size to increase as you go down the group. Then the atomic radii, or the atomic radius, is bigger than the ionic radius for alkaline earth metals. Reason being, they form ions by losing the 2 electrons from the outermost energy level. Hence, the resulting ion has 1 occupied energy level less than the corresponding atom. So the atomic radius is bigger than the ionic radius. That is because when an alkaline earth metal is reacting, or when it is forming a stable when it is forming the stability, that is 2:8 or 2:8:8, or that is 2:8:8, it needs to lose 2 electrons in the outermost energy level, meaning the entire energy level will be lost, making the ion to be smaller than the atom. So the size of the atom is larger than the size of the ion. So next we are going to look at the physical properties of alkaline earth metals. And the first physical property we are going to start with is the appearance and ease of cutting. So when alkaline earth metals is polished, it acquires a metallic luster. Then alkaline earth metals lose their metallic structure when exposed to air. This is because they react by air and they get oxidized. So they lose this metallic structure as soon as they are cut due to oxidation. Then the purpose of polishing the alkaline earth metals is the purpose of polishing the alkaline earth metals before using them in an experiment is to remove the thin layer of the oxide that usually forms on the surface. So we said when we cut an alkaline earth metal, it forms a layer. It reacts with oxygen, so it forms an oxide. So that layer must be polished or removed before using the metals in an experiment to remove this oxide. Otherwise, we are not going to get the expected results. Then, alkaline earth metals are very hard to cut with a knife, and we say that magnesium is ductile and malleable, while calcium is said to be brittle. And for a ductile material, we say that a material is ductile if it can be drawn to wires. And also, magnesium is malleable, meaning it can be hammered into sheets. Being brittle, a substance being brittle is one which is hard and can break. It can maybe break when hammered. So calcium is brittle, while magnesium is ductile and malleable. Property number 2 is the melting and boiling point. So the melting and boiling points of alkaline earth metals decreases down the group. Reason: this is due to decrease in the strength of the forces of attraction holding the atoms together as the atomic size increases down the group. So this is very easy to explain, since the forces of attraction between the atoms decreases down the group. That means the melting point and the boiling point will decrease. So the melting point decreased down the group due to the decrease in strength of the forces of attractions holding the atoms together. So for example, magnesium has higher melting points than calcium, since magnesium has a smaller atomic size. This means the forces of attraction holding the atoms of magnesium together are stronger than that of calcium, which has a larger atomic size. So that makes the melting point and the boiling point also for magnesium to be higher than that of calcium. So that is the explanation we give for the decrease in melting and boiling point of alkaline metals down the group. Next property is the ionization energy. we defined what is the ionization energy, and we said ionization energy is the minimum energy required to remove an electron from the outermost energy level of an atom in its gaseous state. So this energy that we are requiring to remove an electron from an atom in its gaseous state is what we are calling ionization energy. So for the group 2 elements, or what we are referring to as the alkaline earth metals, they have the first and second energy level, ionization energy, I mean, because it has to lose 2 electrons, and these 2 electrons are not lost at the same time. So the first ionization energy is for losing the first electron, and the second ionization energy is for losing the second electron. So the first ionization energy of group 2 elements, or the alkaline earth metals, decreases down the group. Reason: this is due to the decrease in the strength of the forces of attraction holding the atoms together as the atomic size increases down the group. So this is the explanation you give to the decrease in ionization energy down the group. So we say this is because of the decrease in the strength of forces of attraction holding the atoms together. So then the second ionization energy is always higher than the first ionization energy. And that is simply because when one electron is lost from an atom, then remember the positive charge in the nucleus will remain the same. So it holds now the remaining electrons more firmly than when the first electron was not removed. So the second ionization energy is higher than the first ionization energy because once an electron is lost from an atom, the overall positive charge holds the remaining electrons more firmly. The next property we look at is electrical conductivity. So we said for metals to conduct electricity is if these metals has delocalized electrons. So for alkaline earth metals, they are delocalized electrons, that is the 2 electrons that are being lost during a reaction. So alkaline earth metals are good conductors of both heat and electricity, and this is because there's presence of delocalized electrons in these structures. Then all these members of alkaline metals has 2 electrons in the outermost energy level. So these are the electrons that are being lost. So these are the delocalized electrons. And since all of them has two electrons, therefore they have similar conductivity. So we cannot say that one conducts electricity more than the other. So they have similar conductivity. So that is how we explain the electrical conductivity of alkaline earth metals. So that is our part 3. Let's meet in our next lesson where we are going to discuss the chemical properties and also the uses of alkaline earth metals.